Earlier we saw that when p was equal to 1, so if it was 1 over x, it was divergent. Okay. When p was equal to 2, we saw that it was actually convergent. Right? That was the first and second example that we discussed. So what about if it was 1.2? What about if it was 1.3? There has to be some value in between 1 and 2, right? Some value between 1 and 2. That's like a breaking point, which makes it convergent or divergent. Okay, and this solving this general case will answer that for us. Okay, so let's do this. This is an improper integral, right? Set as a limit question, 1 to t. This is x to the power minus p. The antiderivative of that will be 1 over minus p plus 1, x to the power of minus p plus 1, right? And in here we gotta plug in 1 and t. 1 and t. So if you insert t, okay, we can leave the 1 minus p. I'm going to write it as, instead of minus p plus 1, 1 minus p. If you plug in t, you get t is equal to, t to the power of minus p plus 1. Plug in 1, anything, 1 to the power of anything is 1, right? So you get this. Okay, and then we have limit t approaches to infinity. So what is the key to making this converge? This t is the key to converge.
Positive. Is it?
What must be positive?
The t value has to be.
T value is always positive. That's not a question, right? That we know that's going to approach infinity.
Like greater than 1.
Why? Okay, t to the power of any, let's say, number, right? Or x to the power of t. So let's say you have x to the power of like 3, right? And as x approaches to infinity, what happens to this? Infinity, right? So in what case scenario does it converge? When you have what kind of exponent up here? A negative exponent, such as 1 over x. Right? So the key for this to converge is that minus p plus 1 better be negative. Right? That's the key, right? This exponent must be negative so that this becomes a fraction expression. Right? So that this is fraction. Okay? Or t is on the denominator, more specifically, right? So from here you can see that will be like this. So p would have to be greater than 1, right? If you solve for p. So look, let's go back to how we introduced this question. When it was equal to 1, it was diverging, right? So it turns out, even if it's slightly bigger than 1, 1.001, right? It'll still converge. Okay, so integration from 1 to infinity, or any constant that's positive to infinity, right? This converges if p is greater than 1, and this is going to be really important later. Okay, it's called p series test. Okay, we're going to use it a lot. Okay, not in this chapter, but we're going to use it a lot in a little bit.